Hi, my name is Jaron Sambek, and I am in Digital Electronics EE201, and this is my midterm project, the Smart Underwater Camera. So first is description. This is an underwater camera that will turn on when certain criteria are met, and it can also be manually turned on. It will turn off when the manual and standby button are pressed together. This allows for a person to record underwater, and it is particularly useful fishing, as I am a fisherman and I have a camera like this, except it doesn't have these types of functions, and that's why I incorporated it into this camera. First, we have a manual switch, which is a simple on or off switch. Same thing with the standby switch. We have the motion detector, which if motion is detected and a standby switch is pressed, it will turn on. Same thing with the above water trigger. If the trigger is pulled, like say a bobber going under, a flag going up, then the standby switch, and if the standby switch is on, it will turn on. We have the truth tables here. This is just showing that it will turn off when the two buttons are pressed. This is showing the manual on. This is showing the standby and making sure that the standby is off when neither is happening. This is the standby light and just showing that as long as the standby is pressed, it shows the light. We have four expressions: the algebraic expression, the sum of min-terms, and the product of max terms, and the simplified. Algebraic is that big chunk of truths you saw. The sum of min-terms is basically just the sum of those. Product of max terms is the opposite. And the simplified we will get from the sum of min-terms, which using the complementive, which is the C naught plus C, using the distributive C D naught plus D going into C plus D. This will go down to 1, which using the identity will cancel out. We get left with this final expression. And using the K-map, we can actually show it a lot simpler. Using the implicants, there's 3 implicants right here. It just shows that if manual's on and the standby is not on, it still stays on. If manual's off but the standby is on, if motion is detected, or if the above water trigger is pulled, it will turn on. Same thing here with this. You have just the light, which is just as long as the standby light's pressed, you're good. Then you have the circuits, which is basically the simplified versions of both. What I showed you in the K-maps is just the circuit versions of those. And this is the NAND circuits, and NAND circuits are incorporated into each circuit. As you'll see, a NAND into another NAND will AND the terms. So there was an AND gate here, and I NANDed it. So there I incorporated 2 NAND gates. Same thing with, there was a NOT gate, and you could NAND the NOT gate. Now, when testing the prototype, I showed that this light would turn on under certain conditions, and this light would also turn on under certain conditions. And you can see this in this video right here. As I was rushing underneath the time limit I had, I think I rushed a little bit too fast, but I think I explained everything in full. If you want to know more, just ask me in class. I'm Jaron.Sandbeck at ndus.edu. I mean, if you have any questions, it is nice to answer those. Um, as I like to say, this was a fun project, and it was nice to use Boolean algebra as well as K-maps and other stuff we've learned along the way. And I hope that your projects or also go well. So I hope you have a good day, and hope you like my underwater camera, because I know if there was something like this in the real world, I could definitely use it when I was going fishing. Thank you.